Life on Earth is supported by sun. Sun radiates energy in the form of heat and light. This energy produced when two hydrogen atoms fuse at the core of sun.
It's not a simple process when two protons, which is of positive charge, collides together with an immense force, result into helium atom formation along with huge amount of heat and light. Solar energy is an inexhaustible, sustainable and cleanest form of energy.
You know what? The amount of sunlight strikes at the Earth's surface for 90 minutes is sufficient to handle the entire world energy consumption for a year.
Now you can imagine how important it is to convert the most precious everlasting energy of sun into a most demanded form of energy for mankind advancement, that is electricity. And that can be done by the use of solar panel. Solar energy can be converted to electricity by solar panel or solar cell. Most people are familiar with solar panels because these days we can see them everywhere. The solar cells are made up of silicon, a semiconductor. The starting material for silicon is sand. Conversion starts by heating the sand with carbon in an electric furnace to a temperature around 2000 degrees Celsius, which produce carbon monoxide and silicon. The product of this process is 99% pure silicon. To further purify it, a fine powder of silica reacts with gaseous hydrogen chloride at 300 degrees Celsius to give a liquid compound trichlorosilane. The purified trichlorosilane is then reacted with hydrogen gas at 1100 degrees Celsius to finally get purest form of silicon, which then cut into slices called silicon wafer. These slices are used to make solar panel. Silicon atoms are having 4 valencies, which means one atom of silicon bonds with 4 other silicon atoms. Each solar panel cells is made up of 2 layers of semiconducting silicon. One layer has a positive charge and the other a negative charge. The charges are added to each layer by adding another materials to the silicon. For example, pentavalent phosphorus is commonly added with silicon, which results in excess of electron and make it n-type semiconductor, while triboron addition creates electron deficiency and make it p-type semiconductor. When the sun shines onto n-type silicon panel, the excess electron in n-type region gain energy by photons and start moving towards p-type panel, while holes on p-type region starts moving towards n-type panel. The holes and electron meet at the junction known as depletion layer, and this layer becomes neutral because of presence of both electrons and positively charged holes. Now the n-type panel become positively charged while p-type panel become negatively charged. Electric field will definitely be formed due to charges. Now when the sunlight hits the p-n junction, it starts generating electron-hole pair in the depletion region. Electrons start moving towards the positive region while holes start moving towards negative region. The concentration of electron and proton becomes so high that the potential difference will develop between p and n region. Metal conductive plates on both cells and the wire connecting them forms a circuit which allows the free electron to flow as DC electric current. The electric current can be stored or connected directly to the grid.
So far, everything looks cool, right? But the problem starts with its lifespan. The average lifespan of a solar panel is roughly around 25 to 30 years, and after that they start producing less electricity, because of which they would become of no use and they will be replaced by a new solar panel, which generates a lot of waste in the form of silicon. Scientists has estimated that by the year of 2050, our Earth will be end up with 60 million tons of silicon waste. But don't worry, our scientist has found out the solution for this. I'll cover this in my next video.
See you in the next video. Till then, stay safe and be happy.